Hi students, in this video we're going to look at the factor theorem, the sister, brother, cousin, whatever relative you want, of the remainder theorem. Alright, so after watching this video, you should be able to recall that when a remainder is 0, then the divisor is a factor of the value we started with. You should also use the factor theorem to do two things: to decide if a linear expression is a factor, and then also use that factor theorem to identify and find factors of a polynomial. Alright, so some things to recall. We have to remember, going back to our polynomial division lesson, is we can express our polynomial of the form p of x equals x minus a, which is our divisor, times q of x, our quotient function, and r is our remainder. Another thing to remember is our remainder theorem. So when p of x is divided by x minus a, then the remainder is equal to the value of our polynomial with that a value subbed in. A final thing to remember, covered in previous maths courses and learnings, is that some number a is a factor of b if b divided by a has a remainder of 0. Just considering that, if you've got 12 divided by 3, that's 4 remainder 0, then 3 is a factor of 12. If you have 12 divided by 5, that'll be 2 remainder 2. You've got a remainder there. So 5 is not a factor of 12. Something you've done in the past, but just putting some words behind it. If there's a remainder of 0, then a is a factor of b. Alright, so considering our polynomial, p of x equals x minus a qx plus r, so the one we've been considering for the last couple of lessons, if our remainder is 0, then our polynomial becomes p of x equals x minus a times q of x. Now, and that means, because there's a remainder of 0, no remainder, x minus a must be a factor of our polynomial. So with no remainder, as we've discussed already, if there's no remainder, then x minus a must be a factor of our polynomial. Now recall, learned in our last lesson looking at the remainder theorem, that the remainder is equal to the value of our polynomial when our a value is subbed in. So in this situation where x minus a is a factor, then when we substitute a into our polynomial, it should give us 0 because our remainder is 0. And this result is what we call the factor theorem. So for a polynomial p of x, if we substitute in the value a and get 0, that is, our remainder is 0, then x minus a must be a factor of our polynomial because things are factors of other numbers if those remainders are equal to 0. Now let's use that to solve some problems. Alright, so in this first example we just have to determine whether or not these expressions are in fact factors of p of x. Now how we're just going to do that is apply our factor theorem that says if we substitute in our a value and we get 0, that means our remainder is 0, which means our expression is a factor. So just like there's no remainder when you do 6 divided by 3, that makes 3 a factor of 6. The same thing happens here. If we have a value of 0 when we substitute in our a value, that means there's no remainder, which means our expression is a factor of our polynomial, just like 3 is a factor of 6 because there's no remainder. Alright, so doing this first one, looking at our term here, our a value is the opposite sign, so it's positive 2. And then let's substitute positive 2 into our equation. 2 cubed minus 2 times 2 squared minus 13 times 2 minus 10. And that definitely is not going to be 0. That's 8 minus 2 squared is 4 minus times 2 is 8 minus 26 minus 10 equals negative 36. That does not equal 0, so therefore x minus 2 is not a factor, because actually when you divide our polynomial by x minus 2, the remainder is actually negative 36. So it's definitely not a factor. All right, let's try the next one. Let's say a this time equals 5. The value of our polynomial at 5 equals 5 cubed minus 2 times 5 squared minus 13 times 5 minus 10. 5 cubed is 125 minus 5 squared is 25 times 2 is 50. Negative 13 times 5 is negative 65, and minus 10. Funnily enough, put all those together, you get 0. So that means when we divide our polynomial by x minus 5, there is a remainder of 0, which means we must have a factor here. So therefore, x minus 5 is a factor of p of x. All right, let's do one more example. We need to determine one factor of this polynomial, p of x equals x cubed minus 4x squared plus 2x plus 3. A good first step for this problem is look at your constant and know that our value for a must be a factor of that constant. So it could be 1 or it could be 3. Now we should also include our negatives, so it could also be negative 1 or negative 3. Any of those values could be an a value that gives us, that helps us work out our factor. So what we're going to do is just try sum. So let's try subbing in 1 into our equation. 1 cubed minus 4 times 1 squared plus 2 times 1 plus 3. That's 1 minus 4 plus 2 plus 3. That will not equal 1, it'll equal 2. And that's not what we want. We want our value to equal 0 so we can get our factor. Right? If our value, when we sub it in, equals 0, our remainder is 0, which means we've got our factor. So 1 did not work. Let's try negative 1. Negative 1 cubed minus 4 times negative 1 squared plus 2 times negative 1 plus 3. Negative 1 minus 4 minus 2 plus 3. Negative 5, negative 7, that equals negative 4, which is not 0, so that's not a factor either. All right, let's try 3. Right. Once again, we can try 3 because 3 is a factor of that last term there. 3 cubed minus 4 times 3 squared plus 2 times 3 plus 3. All right, 27 minus 3 squared is 9 times 4 is 36 plus 2 times 3 is 6 plus 3. Putting that together, negative 27 minus 36 is negative 9, plus 6 is negative 3, negative 3 plus 3 is 0. There we go. We've got a value that gives our polynomial a value of 0. So that means a must be 3. So therefore, x minus 3, remember our formula is x minus a, is a factor, minus sign, so x minus 3 is a factor of p of x, because when we substitute in 3, it gives us that value of 0. Alright, so after watching this video, you should be able to recall that when a remainder is 0, the divisor is a factor, and then use the factor theorem to decide if a linear expression is a factor of a polynomial, or use the factor theorem to identify or find the linear factor of a polynomial.